Hello everybody and welcome back to another brainstorm. Today we're going to be talking about crude oils and alkanes. Now this is part of the organic chemistry series that I'm doing, so make sure you check that out. But in this video we're going to be talking about three things. First of all, we're going to be talking about what is a crude oil and how are they formed. Then we're going to discuss what are the alkanes and finish off by talking about three of the reactions associated with the alkanes. So let's get into it. So guys, now let's discuss what exactly is a crude oil. The first thing that we know is that a crude oil is a finite resource. What this means is that eventually they will run out. And we also know that they're found inside the Earth's crust, so for us that means that they're underground. Now crude oils are a complex mixture of hydrocarbons. What this means is that because they're a mixture, they can easily be separated using our separator techniques, and we will be discussing that later. And because they're hydrocarbons, they are only made out of hydrogen and carbon atoms, nothing else. In terms of everyday uses of crude oils, we usually use them for fuels, solvents, and lubricants for some machinery. Alright guys, so now we know what the crude oils are, let's talk about how exactly were they formed. So crude oils are found in rocks in the Earth's crust, like we previously said, for us that would be underground. And they were formed over millions of years, so they took a very long time to make these crude oils. And they're made from the remains of organisms, and now these organisms were actually buried in mud. What do we mean by organisms? So these are basically living things that have died. This can include plants, sea animals, but they're mainly made out of an organism known as a plankton. And the conditions that these crude oils were made in were high pressure, high temperature, and anaerobically, so that means without oxygen. We also need to know that fractional distillation is the separation technique that's used to separate crude oils because of their different boiling points. I'm not actually going to go into much detail about what fractional distillation is, but all we need to know for this is that fractional distillation involves a large column known as a fractionating column, and the crude oils are heated up in here. Now the crude oil which has the lowest boiling point will be separated off first and collected through condensation, so on and so forth, the one with the next highest boiling point, until we get the one which has the very highest boiling point at the bottom. Now these crude oils generally aren't really of much use to us, they can't be made into fuels, so they end up just be collected as sludge at the bottom of this column. That's all we really need to know about fractional distillation. Alright, so now let's discuss what are the alkanes. So from these crude oils that we've just discussed, one of the main products that we get are these chemical molecules known as alkanes. Now alkanes are saturated hydrocarbons. What we mean by that is you'll remember that hydrocarbon is a molecule made out of only hydrogen and carbon atoms. And what we mean by saturated is that every carbon atom has the potential really to bond to 4 other atoms. And when it's saturated means that no bond is left unbonded. Every carbon atom is either bonded to another carbon or 3 hydrogen. And they all have single covalent bonds between their atoms, and this is contrasting to ionic bonds or double covalent bonds, but these guys just have simple single covalent bonds. We also need to know that all of the alkanes have this general formula of CnH2n plus 2. What this means is that for every carbon atom that we have 2 times that amount of carbon atoms plus 2. So for example, if our alkane had 2 carbon atoms, we can find out how many hydrogen atoms it has if we times this number by 2, so 4, and add 2 to it, 6. C2H6, that would be our formula for the alkane. You can also see here the first 3 alkanes, and for this we can see that they're all saturated, so all of the carbons are bonded to 4 other atoms. We can see that they're hydrocarbons because we can only see hydrogen and carbon atoms here, and they all follow this single general formula rule. Alright guys, so these are 2 other concepts that we have to know about in organic chemistry, and that's the functional group and the homologous series. So first of all, the functional group is a group of atoms responsible for the characteristic reactions of a particular compound. So for our alkanes, we don't really have a functional group, but some people consider the single bond between the carbon atoms to be the functional group. And it would be this single bond that makes sure that the alkanes react in reactions the way they do, and they have the particular characteristics that they do as well. Next, homologous series is a sequence of compounds which have the same functional group and similar chemical properties. So in our case, the homologous series is the alkanes. We know that they all have this functional group, and they will all have similar chemical properties, which means that they behave in reactions in the same way as well. So these are our first 4 alkanes in the homologous series: methane, ethane, propane, and butane. Note the first part of these words is meth, eth, prop, and bute. The way that I remember this is a mnemonic: monkeys eat peanut butter, M-E-P-B. And all of these words also end in ane, which is characteristic for any alkane that we have. Now we can use the general formula which we previously learnt, CnH2n plus 2, to actually work out the chemical formula for any of these alkanes. So the reason that methane is the first in this homologous series is that it only has 1 carbon atom. We can work out how many hydrogen atoms it has if we times 1 times 2, which is 2, add 2, which is 4. So we know that the chemical formula for this is going to be CH4. Ethane is going to be C2H6. Propane, C3H8. And butane, C4H10. Alright guys, so now we're going to talk about the reactions of alkanes, and there's 3 that we're going to talk about in this video. First of all, we have a complete combustion, an incomplete combustion, and cracking. Before we get into those, just note that combustion is a reaction of the alkanes with oxygen. Okay, so let's start off with the complete combustion. So with a complete combustion, we'll react the alkane with oxygen, and that produces carbon dioxide and water. So let's think of an example. If we take our simplest alkane, CH4, and note that that's methane, and then we react that with our oxygen, we know that that will become carbon dioxide and water. Then we can balance up that equation, as so. And the reason that this reaction is a complete combustion in comparison to an incomplete combustion is that we have plenty of oxygen. Okay, plenty of oxygen to react the alkane with. Alright guys, so we've talked about the complete combustion of alkanes. Now let's talk about the incomplete combustion. So in the same way, we're going to react our alkane with oxygen, but this time we produce carbon monoxide, carbon, and then water again. The thing we need to know about carbon monoxide compared to carbon dioxide is that carbon monoxide is actually poisonous to us humans because it binds to the red blood cells in our body and means that they don't have enough space to bind to oxygen, and that's how we get carbon monoxide poisoning. The carbon emitted as well is also emitted in the form of soot, which is harmful to the environment because it is a big polluter in our atmosphere. So the reason that this is incomplete combustion compared to complete combustion is that this time we have not enough oxygen. So you'll remember that for the complete combustion we had plenty of oxygen, this time we don't have enough. So in the same way, we're going to take CH4, our simplest alkane, methane. We're going to add to that oxygen, and we know that in incomplete combustion we produce carbon monoxide, carbon, and water. Then we can balance that up, as you can see here, 4, 5, 2, 2, 8. And that's our incomplete combustion of methane. Alright guys, so the final reaction that we're going to look at for the alkanes is a process known as cracking. Now the main principle of cracking is we take a larger alkane and convert it into smaller alkanes plus an alkene. Now an alkene is an entirely different molecule to the alkanes, and we don't want to mix the two up. We're not going to go into much detail about these because that is what we're going to come on to in part 2 of the organic chemistry series, so make sure you check that out. So the reason that we convert a medium scale alkane into a smaller alkane is because these smaller alkanes are generally more useful. So for example, the fuels in most of our vehicles are smaller scale alkanes. We also need to know the conditions that this reaction takes place in. So it takes place in the presence of a catalyst and at 500 degrees Celsius, so very high temperatures. So if we take a medium scale alkane such as decane with 10 carbons, in the presence of our high temperature and our catalyst, we can convert this into pentane, which is our smaller alkane here, and we convert it into 2 alkenes as well, propene and ethene. We don't need to worry too much about them right now. Also note that it doesn't matter which alkanes and alkenes we convert it into, as long as all of the carbon and hydrogen atoms on this side of the equation add up to the ones on this side. Alright guys, so let's wrap up this video by quickly recapping everything that we've learned today. So we started off by talking about crude oils, which we know are a finite resource that we find in the Earth's crust, so underground. Finite meaning that they will eventually run out. We found out that crude oils are formed from the remains of organisms such as sea plants, animals, and mainly plankton over millions of years. And you also remember the 3 conditions that they're produced in: high temperatures, high pressures, and without oxygen, so anaerobically. Then we quickly discussed the 3 uses of crude oils. They're mainly used as fuels, lubricants, and solvents. Finally, you remember that these are a mixture of hydrocarbons, meaning that we can separate them in a process known as fractional distillation, which separates them based on their different boiling points. Then we talked about alkanes, so these are the main products that we get from crude oils, and these are a form of saturated hydrocarbons. Remembering that hydrocarbons is a molecule that's made out of just hydrogen and carbon atoms, and these alkanes have a single bond, covalent bond between the carbons. Saturated means that every carbon is bonded to 4 other atoms. You remember in the homologous series for the alkanes, the first 4 that we had were methane, ethane, propane, and butane. And you remember that analogy I gave you guys, monkeys eat peanut butter. Then we went on to talk about the 3 reactions that we see with alkanes. We had complete and incomplete combustion, which you remember is just reacting them with oxygen. Complete combustion produces carbon dioxide and water, and this has plenty of oxygen to react the alkanes with. Whereas incomplete combustion produces carbon monoxide, carbon, and water, and this is because there isn't enough oxygen. Finally, we talked about cracking, which is the process where we take a larger alkane, convert it into a smaller alkane plus an alkene. And also with these alkanes, you remember that we talked about a general formula for them, which was CnH2n plus 2, which we can use to find the chemical formula of any alkane if we know how many carbon or hydrogen atoms it has. And with that, I'd just like to say thank you guys for watching. Make sure you hit like and subscribe if you want to see more videos like this, and also be sure to check out the rest of the organic chemistry series, and I'll see you guys soon.